Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from beta gamma functions, right? In our earlier videos we have already solved a number of problems related to a beta gamma function, right? So in this lecture we'll solve this important integral in which we'll make use of the definition of gamma function, right? So let us start and let us see how we can easily solve this type of integral by the method of substitution, right? So let us first call this integral as I, right? Now see, in the denominator we have 2x plus 3 raised to 6, right? And the overall integrand is x cube divided by 2x plus 3 raised to 6, right? So what we will do, we'll take 2x is equal to uh, 3t, right? So here we are introducing this variable t, right? So why we are writing 2x is equal to 3t? Because see, this term 2x plus 3, when we take 2x is equal to 3t and substituting 2x is equal to 3t in this expression, we have 3t plus 3, right? And we can easily see that we can take 3 common from this term, that is t plus 1, right? So that's why we are taking this substitution, 2x is equal to 3t, right? So when 2x is equal to 3t, then we have x is equal to 3t over 2, right? So let us differentiate both sides with respect to t. So dx over dt is equal to 3 by 2 times 1, because the derivative of t with respect to t is 1. So we have 3 by 2, right? So now dx can be written as 3 by 2 times dt, right? So now we have dx is equal to 3 by 2 times dt, and let us change the limits accordingly. So here x varies from 0 to infinity, right? So when x is equal to 0, we can find out the value of t by substituting x is equal to 0 in this relation. So we have 3t is equal to 2 times 0, that is 0. So t is equal to 0 divided by 3, that is 0, right? And when we have x is equal to here infinity, then we have 3t is equal to 2 times infinity, that is simply infinity, and t is equal to infinite, right? So now we can rewrite this integral I in terms of t, right? So the limits remains the same. So t varies from 0 to infinity. For x cube, we have 3t over 2 raised to 3, and for dx we can now write 3 by 2 dt, right? Okay, and in the denominator we have 2x, so 2x can be replaced by 3t, and here we have 3, and this is raised to 6, right? So now what we have to do, we have to take the constant terms out of the integral. So here we have 3 cube, 3 cube is 27, 2 cube is 8, right? And here we have 3 by 2, and now we have 0 to infinity. We are simply left with t cube, and here we have dt. And see, here if we take 3 common, then we have 3 raised to 6 and t plus 1 raised to 6, right? Okay, so now we can take this 3 raised to 6 from this integral. So we have here 27 3s are 81, and 8 2s are 16, and then we have 3 raised to 6 outside the integral. We have 0 to infinity. We have t cube dt divided by t plus 1 raised to 6, which can be written as 1 plus t, because t plus 1 and 1 plus t are same. So here we have 6, right? So now let us simplify these terms which are outside the integral. So here we have 81 and here we have 16, and 3 raised to 6 is 729, right? And now see this integral, right? So here we have 0 to infinity. Now see, t cube can be written as t raised to 4 minus 1, right? So 4 minus 1 is 3. So why we are writing? Because we are now converting this integral into beta function, right? So t cube can be written as 4 minus 1, and 1 plus t raised to 6 can be written as 4 plus 2, right? Because 6, we can split 6 as 4 plus 2. So now viewers, so we can simplify this expression. So here we have 81, 9s are 729, and 16 times 9 is 144, right? And here we have 0 to infinity, and t raised to 4 minus 1, we have 1 plus t raised to 4 plus 2 dt, right? So now our integral, it looks like this, right? Okay, now here we have to use the definition of beta function, right? So now see, the beta integral, we have already discussed a lot about this function in our earlier videos. So the beta function, that is beta mn, can also be defined by this integral, that is 0 to infinity x raised to m minus 1 and 1 plus x raised to m plus n, right? So this is another definition of beta integral, right? So now see, our this integral is exactly same as this one, except the variable. Here we have the variable t, here we have the variable x, right? So we can ignore it because this is a dummy variable. So here x raised to m minus 1, 1 plus x raised to m plus n. So if we compare this integrand with this one, then we can see that m is equal to 4 and n is equal to 2, right? Because this is m, and this is our n, right? So now our integral I can be written as 1 over 144, and here we can replace this integral by beta of mn. Mn is 4 comma 2, right? So now viewers, we have to find out the value of beta 4 comma 2, right? So we know that beta mn is defined in terms of gamma function, that is gamma of m, gamma of n divided by gamma of m plus n, right? So here beta 4 comma 2 is equal to gamma of 4, gamma of 2, gamma of m plus n. So 4 plus 2 is 6, right? So here I will make use of one important result from gamma function. So gamma of n plus 1 is equal to n factorial, right? Where n is greater than 0. So here we have gamma of 4. So gamma of 4 can be written as 3 factorial. Gamma of 2 can be written as 1 factorial. Gamma of 6 can be written as 5 factorial, right? See, gamma of 4 can be written as gamma of 3 plus 1. So here n is 3. So we have 3 factorial. And likewise, here we have gamma of 2 and gamma of 6, right? So 3 factorial is simply 6. 1 factorial is 1. And 5 factorial is 120, right? So this is 1 over 6 to the 12. So we have 1 over 20. So now the value of I is 1 over 144 times 1 over 20, right? So beta of 4 comma 2 is 1 over 20. So now we can multiply these two numbers. and we'll get 1 over 2880, right? So whereas the value of this integral is equal to 1 over 2880, right? So this is how by making use of this definition of gamma beta function we can solve these kind of integrals.